Solving a math problem that has no solution. It doesn't have an answer. Person came to me and they had this math problem that nobody could figure out how to solve. And they're like, I don't understand why we can't solve this. We've got this math problem, and everybody I asked, they're like, there's no answer to this problem. So, of course, I had to look at it and I'm like, don't ask Dad. Ask me when you got a math problem that you can't solve. Becky was given a piggy bank on her 10th birthday, and she put it to use right away. Each time she puts coins into the piggy bank, she keeps track of the number of coins she has collected and the accumulated value of her collection. Becky collects only nickels, dimes, and quarters. 7 months after her 10th birthday, Becky looked at her record and determined that she had collected 240 coins, which were worth $36. The question is, how many combinations of coins are possible in Becky's collection? So I started thinking about that, and what is so typical of word problems is there's a whole bunch of words in there that we don't need. Becky, her birthday, how old she is, none of that stuff matters. It just makes the problem more interesting, but more likely what it really does is it just confuses us on what we need to do. So the important bits of information are $240 coins. She collects nickels, dimes, and quarters, and it's worth $36. That's what's the most important thing. All the other stuff that's in there doesn't really apply to the question. So why can't we solve this? Because people want an answer to a math problem. And the reason, if we think about this, is what we have here is we have, quote, two equations. We have nickels plus dimes plus quarters equals the 240 coins. This equation here is just counting the coins. 1, 2, 3, 4, 5. Doesn't have anything to do with the value, just a numerical count. And then if we want to think about the money part of it, is 0, 5, because a nickel's worth 5 cents, plus 10 cents for a dime, plus 25 cents for a quarter, and this is going to equal our $36. Now, for me, we can solve it like this with decimals, but decimal numbers are hard on the brain. So I like to make things whole numbers when I can, because whole numbers are happy numbers. So if we think about it, we can just take the decimal off here. A nickel's 5 cents, a dime's 10 cents, a quarter's 25 cents, and then we've got to put 2 more zeros, because basically what we've done is multiply everything, and as long as we multiply everything in the equation by the same number 100, it equals that. So, 5 pennies, 10 pennies, 25 pennies, and $36 is 3,600 pennies. So the problem that we have here is this is what's called the system of equations, and we have 2 equations, but we have 3 unknowns. And that is why people say there's no answer to the problem, which is correct. There is no one answer to the problem. But if we look back at what Becky, that's the person in the problem. If we look back at what the student is supposed to find, how many combinations of coins are possible in Becky's collection? So we know we're going to actually have a bunch of answers. So I solved this problem with the student, and it was really mathy, intense math, and I'm sure most of the time the student was going like this, but had no idea what I was talking about. And we did get to the answer. So then once I had the answer, last night I'm sitting here going over it in my brain. I'm like, there has got to be a common sense, easy way to solve this problem, to find answers to the problem. And now that once I actually knew the answer, then I could think back and I came up with it. And it hit me like a brick that, you know, the instances, we know we're going to have quarters because that's the only way we can make these numbers here. So on one extreme, we can get rid of the nickels. Now we have two equations with two unknowns. We can solve this. And then we can put the nickels back and erase the dimes and solve that. And we'll get two answers. So if we just go ahead and do this, what we'll do is if we multiply this by 10, this by 10, this by 10, and if we subtract this equation from this equation, the dimes go away. 25 minus 10 is 15 quarters equals 3,600 minus 2,400 is 1,200. And then if we divide this by 15, divide this by 15, the number of quarters equals 1,200 divided by 15 is 80. So the number of quarters is going to equal 80 in this instance. Now let's put our nickels back. And erase our dimes here. Now this time we'll multiply this one by 5. So we've got 5 quarters here, pardon the mess. And 240 times 5. 5 times 240, 0, 20, 1,200. All right. Little math on the side there. 1,200. Now we'll subtract again. So the nickels cancel. 25 minus 5 is now we have 20 quarters. 3,600 minus 1,200 is 2,400. Now we divide this by 20, divide this by 20, and the 20s cancel. And 240 divided by 20 is 120. So in this instance, the quarters equals 120. So what do we have here? If we don't have any dimes, only nickels and quarters, we have to have 120 quarters, and then we would have 120 nickels to make the 240, and that adds up to $36. And over here, if we didn't have any nickels, we have 80 quarters, then we have to have 160 dimes, and it's the same thing. So we've got these two extremes. Now, every time we add a quarter, we've got to adjust the nickels. We have all the numbers in between. So if we think about that, from 80 to 120 is 40 values, but we also have to count the number that we started with because it's 81, 82, 83. We got to count the 80. So in this case, there are 41 possible answers to the number of quarters, because we could have 80 quarters, 81 quarters, 82 quarters, 83 quarters, and then we start off with all dimes here, and then we get rid of dimes and we add nickels till we end up over here with all quarters and all nickels. So there is the solution to a problem that has no solution. We actually have 41 possible answers to the 240 coins of nickels, dimes, and quarters. That adds up to $36. Don't ask Dad, ask me, because my goal is to help you understand math using normal, everyday, simple English. And forget all those crazy math equations. This is simple, right? Watch another video and subscribe, so you'll be up to date on the next problem. And if you have a math problem, ask me.